Chapter 7 Cosmology, the Milky Way Galaxy. We live among a vast number of organized stars called a galaxy. Our system is called Milky Way Galaxy, or MWG. The MWG is composed of billions of stars and appears like a flat rotating disk around a bulging center, like a giant pinwheel gently spinning in space. The MWG is enormous relative to us. Traveling at the speed of light, it would take about 120,000 light years to cross our galaxy from one edge to another. Our nearest neighbor, M31, or the Andromeda Galaxy, is 200 million light years away, while our Sun is 8.5 light minutes away. Components of the galaxy. The MWG has three major parts: the nucleus, the disk, and the halo. The nucleus. The nucleus, or center of the galaxy, is made of millions of densely packed stars. The stars of the nucleus are primarily ancient stars composed of hydrogen and helium. Because there are so many stars in this area, it is believed the stars in the nucleus rotate together as if they were a single body. The disk. The galaxy's disk is composed of concentric arms wrapping around the central nucleus. The arms are made of gas, dust, planets, and billions of stars. The stars in the spiral arms are generally younger, are hotter, and contain more of the heavier elements than the stars in the nucleus. Heavier elements are anything heavier than helium or hydrogen. Hydrogen, the lightest element, comprises about 90% of all known matter. Helium comprises about 4%, while all the other elements combined only comprise about 1% of all known matter. Stars do not come in one standard size and color like our Sun. There is a variety of sizes and colors, ranging from the young hot stars just shedding their nebular cocoons to red supergiant stars like Betelgeuse, which is so large that if it were in the place of our Sun, we would be inside of it. And there are dwarf stars that range in color from white to brown and barely have enough mass to generate a nuclear reaction which is relatively small. And just as there are all kinds of stars, the lives of the different stars vary. It is believed that most smaller stars live quietly, slowly burning up their fuel over billions of years. The star becomes a cold ash in space while the fuel runs out. Larger stars burn up their fuel more quickly and have shorter lives. These stars become unstable and at a certain period and blow off their outer layers in explosions called planetary nebulae, or nova. Some stars might go through a nova sequence many times. Some don't go through it at all. Eventually, they go cold. Supergiant stars are different. Because they are so large, they are able to fuse heavier and heavier elements for fuel. Massive stars can fuse elements up to iron, but when iron accumulates at the core, it requires too much energy to fuse. The star becomes unstable and explodes as a supernova, spreading the building blocks of life for millions of miles. The end result of a supernova explosion is the stellar debris, which appears like a huge cloud of gas and dust. Sometimes neutron stars, pulsars, or theoretical black holes are discovered in the middle of these destroyed giants. Scattered among the stars we can see are many forms of matter that we can't see. One non-luminous body is molecular clouds. The MWG has gigantic molecular clouds of gas and dust, which extend for hundreds of light years. Another example of a non-luminous body is dark matter. Scientists have tried to calculate rotations of some galaxies, but those calculations don't work because there is likely 10 times more matter than that they cannot account for. They know the matter is there, but they can't see it. So they have come up with the concept of dark matter. It is there, they just can't see it. Other examples of non-luminous bodies are planets, comets, asteroids, atoms and molecules, black holes, dust clouds, etc. The halo. The halo contains stray stars, dwarf galaxies, and large groups of stars called globular clusters. The globular clusters pose an enigma, for in them are found a special type of star called the Cepheid variables. Some Cepheid variables are dated at 1 billion years older than the universe. That poses the question, how can a star be older than the universe? There are probably new discoveries I'm not aware of since I wrote this. Our system. Our galaxy has several concentric arms wrapping around the nucleus. Our Sun orbits in the Orion arm about 30,000 to 40,000 light years from the galactic center. There are 8 planets in our system. The 4 inner planets are rocky terrestrial worlds: Mercury, Venus, Earth, and then Mars. After Mars, there's a band of cosmic debris called the asteroid belt. The 4 gas giants orbit outside the asteroid belt: Jupiter, Saturn, Neptune, and Uranus. Each of these giants has its own system and is orbited by rings and moons. Distances in our solar system are measured by astronomical units, or AUs. 1 AU is the distance from the Sun to the Earth, which is 93 million miles, or 8.5 light minutes. So if it takes light 8.5 minutes to reach us, we are seeing the Sun as it was 8.5 minutes in the past, and we are seeing our neighbor, the Andromeda Galaxy, as it was 200 million years ago. There must be other planets with life. If our star system has a planet with life, then there must be worlds that are capable of supporting life, or which already have had life orbiting some of the billions of other stars. This is not a unique concept embraced by a few sci-fi fanatics. The Lord himself taught, "And worlds without number have I created, and I also created them for mine own purpose. And by the Son I created them, which is my only begotten. And the first man of all men have I called Adam, which is many. But only an account of this earth and the inhabitants thereof give I unto you. For behold, innumerable are they unto man." Another idea worth considering is there are probably many worlds in the process of getting ready for the children of God. There might be some planets where the only living things are primitive algae and bacteria, which have been quietly living and dying for eons in primordial seas. Some worlds might be plunged into deep periods of glaciation where the cold is king, and only the very strongest survive. Other planets might be almost completely covered with water. Perhaps some of these worlds are carpeted with lush green vegetation filled with animal life, and covered in large bodies of water teeming with aquatic creatures. Other planets probably are filled with dinosaurs. There is a lot of matter out there, and I believe that among the stars we can see, there is an innumerable number of planets that we can't see. Some of these must certainly be capable of supporting life, other galaxies. We are not alone as we look beyond our little galaxy and its companions. The sky is saturated with millions of galaxies of different shapes and sizes. There are irregularly shaped dwarf galaxies, spectacular spiral galaxies, and enormous elliptical galaxies span hundreds of millions of light years across. The next major galaxy nearest to us is M31, which has 3 times the mass of the MWG. Some galaxies orbit galaxies, and groups of stars orbit galaxies. Dwarf galaxies and globular clusters surround both Andromeda and MWG. Clusters of galaxies. There is an order to the universe and its galaxies. Astronomers have recognized patterns even in the groupings of galaxies. The MWG is part of an organized group of over 20 members known as the local group. The local group is a much larger group known as a supercluster, a cluster of galaxies. There are also patterns in the motions of the galaxies. It has been noted that most galaxies are moving away from each other. Those closest to us are moving away at slower velocities. Those farther away are moving faster, and the most distant ones are speeding away at incredible rates. We are moving away from some galaxies at over 90% of the speed of light. Was there a Big Bang? While the cosmic video runs in its current direction, the visible universe expands. But if you could stop the tape and watch it go in reverse, it would appear that the galaxies had a common origin. This is one of the reasons scientists have developed the Big Bang theory. Some believe that all matter in the universe was gathered together in one place at one time, and that, somehow, the matter ignited and hurled out in all directions. They believe that the matter did not spread into space, but that space was created as it expanded with the matter. As the matter flew out in all directions, it condensed into the galactic systems we know today. Olber's paradox. Another proponent for the Big Bang Theory is Olber's paradox, which reasons the following. If the universe is infinite, and there is an endless number of stars, then the night should be infinitely bright. So why is the night dark? The night should be bright if there is an infinite number of stars, but the night is dark. The Doppler effect is one of the arguments as to why the night is not luminous. When a train passes by and sounds its horn, the sound pitches high as it approaches you and fades away as the train moves away. The same principle applies to light. Objects moving toward us in space are blue-shifted in the light spectrum, while objects moving away from us are red-shifted. It is common knowledge that the universe is expanding. The galaxies we see in the night sky are moving away from us. Generally speaking, the farther away an object is from us, the faster it moves away. There are distant objects called quasars that were discovered in the 1950s. Quasars are old, much older than the galaxies we see. Astronomers have discovered red-shifted quasars moving away from us with velocities of over 70% of the speed of light that are further away than the most distant galaxies. The deeper you gaze into space, the farther back into time you see. If you could look deep enough into space, eventually you would reach a point past the stars, the galaxies, and the quasars to a point of darkness. Darkness then denotes there was a beginning. The Big Bang and its major theories and its major problems. The Big Bang Theory explains the general expansion of matter, but has some problems. There are 4 issues I will address. Cepheid variables. The first issue is the Cepheid variable. These stars are generally quite old and are found in globular clusters of other ancient stars. The problem is that the Cepheid variables are dated from 16 billion to 19 billion years old. Scientists generally accept that the Big Bang occurred about 15 billion years ago. This would mean that some Cepheids are dated older than the universe and were created before the Big Bang. That would be impossible. The dark matter issue. The second issue is dark matter. Dark matter is material that is there but is difficult to detect, such as nebulous clouds. There is gravitational attraction wherever there is matter. Also, light can't pass through solid objects but is deflected. So how is dark matter affecting the movement of light and matter in the universe? Until the dark matter is resolved, I can't accept the view that because there is darkness, there was a beginning. The life issue. The third issue is the life issue. Some have speculated that simple life originated in primordial seas and then evolved into the myriad of complex organisms we know today. The term simple is relative. Even the most primitive life forms are extremely complex, far too complex to be thrown together in a pond. Those who adhere to the spontaneous creation of life are trying to create life without God. But as will be discussed later, life comes from life. Life comes from God. The God issue. The last issue is God. If there was a Big Bang, there must have been a beginning, a possible end, and no God. God is a participator in this universe, not just a passive observer. People have seen God. He is real. God lives. And He has told us that we are part of an eternity, just as He is. God is not separate from the universe, but is as much a part of the universe as you and me. Summary. Some theorize that because they can't see beyond the horizon, the universe must have a beginning. I believe the Big Bang has too many unanswered questions, and just because there is darkness does not necessarily mean there was a beginning.